a room. Actually, yeah, when a bottle of perfume is left open for some time, yeah, the scent of perfume soon spreads throughout the entire room. It means the particle of perfumes can move into another part of the room. And also, like, yeah, what would happen if your mother is cooking curry? Yeah, it will be same. Yeah, if your mother is cooking curry in the kitchen, yeah, we will soon be able to detect the smell of the spaces in every room. It's also because the particle of curry can move from the one place into another place of the room, and then it will be same with the tea. Yeah, the color from the tea spreading in a solution. Yeah, this is some example of diffusion on daily life. Yeah, diffusion is evidence of the kinetic particle theory. Yeah, we have learned about the kinetic particle theory from the previous lessons. And what evidence can be used to explain the movement of particles? Yeah, the movement of perfume particles, the movement of the color tea particles. Yeah, let's learn the subtopic 1.4 diffusions. Yeah, this is the learning outcome. At the end of the lesson, you should be able to use diffusion to account for the movement of particles in liquids and gas, and state example of daily effect of diffusions, and explains qualitatively the effect of molecular mass and temperature on the rate of diffusions. Let's review first about the kinetic particle theory. Yeah, because we are going to talk about the gas particle and the liquid particle, and then let's compare about the arrangement of the particle in liquid and gas. Yeah, how about the arrangement of particles for the solids? Yeah, we know the solid is orderly, liquid is disorderly, same as the gas disorderly, and then the liquid particle closely pack each other. Yeah, the liquid particle less closely packed than the solid particles, and then the gas particles very far apart one and another. And because the solid particles closely packed each other is why the force of attraction between the particles very strong, and then the liquid particles have strong force of attraction. And because the gas particles very far apart one another, it's why the gas particles very weak force of attractions. And how about the kinetic particle theory? The solid particles have very low kinetic energy. Yeah, you know the kinetic energy is energy to move. It's why the motion of particles of solids only can vibrate and rotate about the fixed positions. But the liquid particles, because they have strong force of attraction, it's why the kinetic energy is low. Yeah, as the result, the particle move freely throughout the liquid. And how about the gas? Yeah, because gas have high kinetic energy, it's why the gas particle can move randomly and rapidly in any direction. Yeah, how do we show diffusions? Yeah, we can show diffusion in the laboratory by using the experiment using the glass jar, two glass jars. Yeah, the first glass jar consists of air, and then the second glass jar consists of bromine gas. It's like red color, reddish brown color, the bromine. Okay, let's watch the video.
Water vapour spreads out into the atmosphere. It's carried by the wind, but it can also spread out of its own accord by a process known as diffusion. Invisible gases behave in the same way. The particles in a gas move randomly in all directions. This helps explain why a gas diffuses from one place to another. You can see diffusion happening on a small scale in the lab, using bromine, an orange-coloured gas. Place a jar of air on top of the bromine, and it slowly starts to spread. It's moving up the tube against gravity. Over time, the two gases mix. After half an hour, both containers have a uniform colour. It takes time because the air and the bromine molecules are colliding with themselves and each other. So what would happen if there was no air for the bromine to bump into?
A few minutes after the cover is removed, the reddish brown color becomes visible throughout the jar. Why? It happens. Let's see this from the experiments. The first jar contains air particles. That is the first jar, and then the second jar contains air particles. The second contains bromine, Br2. So we can see, after minutes later, the air particle mixed with the bromine particles. Why? Because the bromine particles move from the second jar into the first jar. The reddish brown color becomes visible throughout the jar. That is the animations. Let's see the particle of gas, the bromine. This is the particle of bromine gas. This particle of the air. After we remove the lid, a few minutes later, the particle of bromine mixed with the particle of air. And why does diffusion occur? We know both of air and bromine is a gas. Let's recall from the kinetic particle theory. The gas particles always move randomly and rapidly in any directions. It's why the bromine particles diffuse from the high concentration into the lower concentrations. Can't diffuse into the space between air particles. And then the mixture of the air particle and the bromine gas, we can call it as the homogeneous mixture. So let's conclude the diffusions. What is meant by the diffusions? Because the bromine gas move from the high concentration area, is a high concentration, low concentrations. It's why we can conclude that diffusion is the movement of particles from the high concentration into the low concentrations. And why does the diffusion occur? Because we know the gas particle move randomly and rapidly in any directions. It's why this is a process by which particles move freely to fill up of any available space. And do all gas diffuse at the same rate? Let's discuss first about the MR, because the rate of the diffusions is relative to the MR, the relative molecular mass. What is the relative molecular mass? It's the sum of the relative atomic mass of all the atoms in molecules. In a molecules. It is the relative molecular mass of some gases. For example, like hydrogen gas is diatomic mass, a diatomic gas, because consists of two atoms, the hydrogens H2. To calculate the MR, the formula is Ar times total number of atoms. How many hydrogen atoms in the hydrogen's molecules? There are two hydrogens. It means R is equal to Ar of hydrogens times 2, because we have two atoms, hydrogen atoms. And we can get the AR from the periodic tables. It's from the periodic tables. The AR of H is 1 times 2 is equal to. It's why the MR hydrogen 2. How about oxygens? Is AR oxygen times 2 because we have 2 oxygen atoms. Is equal 16 times 2. Okay, it's why 32 for oxygens. And how about the carbon dioxide? Is equal AR carbon plus AR oxygens times 2. Yeah, carbon is 12 plus oxygen 16 times 2. So is equals 12 plus 32 is equal 44. Do all gas diffuse at the same rate? The rate of diffusion of gas is depend on the relative molecular mass. Under the same temperature and pressure, the gas with lower MR will diffuse faster. And how about the particle with a high molecular atomic relative molecular mass will diffuse slower? Okay, it's same with the two peoples with different mass. For example, A have mass 40 kilograms, B have mass 50 kilograms for A, 40 kilograms for B. Move at the same time with opposite directions. A to the right, B to the left at the same time. We can conclude based on the mass, B will move faster than the A. The A will move slower. It's same as the rate of diffusion related to the relative molecular mass. Lower the relative molecular mass, faster the diffusions, faster the rate of diffusion. How do we show that the rate of diffusion is affected by the relative molecular mass? We can use the two solutions, ammonia solutions, NH3 and HCl. We can use it using the glass jar, and this is the cotton. This cotton. Let's watch the video about the rate diffusions based on the MR. Let's see the MR of ammonia and hydrochloric acid. This is the ammonia NH3 and hydrochloric acid HCl. MR of NH3 is equal AR N plus 3 times AR hydrogens. AR N, we can get it from the periodic tables, is 14 plus 3 times 1. That's why 17, the ammonia NH3. And the hydrochloric acids, ARH plus ArCl. It's from periodic table is 1, Cl is 35.5. It's why 35.5 for HCl. We can see from the experiments the ammonium chloride, and this is the ammonium chloride as the product from the reaction ammonia with the hydrochloric acids is the weight float, the solid weight float. The position of the products here, the position of ammonium chloride here. Why not in the middle of the glass jar? It's because the relative molecular mass of the gas ammonia and hydrochloric acids. Because ammonia has lower MR on the 17th, it's why the ammonia particles move faster than the hydrochloric particle. Move slower. So because the MR has a lower MR than the hydrochloric acids. And then next, about diffusion in liquids, we can use the beaker glass, fill it with the tap water, and then add the potassium manganate, the crystal potassium manganate that has a deep purple solutions. Deep purple. After minutes later, the particle of the potassium manganate move from the high concentrations into the low concentrations. Diffusion slowly takes place until the solution becomes uniformly purple. And then next, about the effect of temperature on the rate of diffusions, we can compare the experiment 1 with the experiment 2. Experiment 1, we use the tap water. For example, this experiment 1. The temperature of the tap water is about like 25 degrees Celsius, for example. And after 5 minutes, we can see the mixture from the potassium manganate and the tap water. And what will happen? If we use the boiling water in these experiments. The boiling water, for example, the temperature is about 80 degrees Celsius. As for the second experiments, we only need 2 minutes until the mixture homogeneous. So what is the conclusions? We can conclude that the rate of diffusions affected by the temperature. By increasing the temperatures, the rate of diffusions faster. When the temperature increases, the rate of diffusion increases. Okay, that's about the diffusions. And don't forget to do the test results of 1.4, number 1 until 3. Thank you for your participation. See you later. Bye-bye.